All right, let's get right into it. Today we're talking about polymorphism. And believe me, this is one of those big, powerful ideas in Python. If you're looking to write code that's not just functional, but clean, professional, and easy to scale, then this is something you've absolutely got to get your head around. But first, let me ask you something. Have you ever just stopped and thought about the len function? I mean, we use it all the time, right? On strings, on lists, on dictionaries, and it just works. How does that one little function know how to handle all these completely different kinds of data? Well, it's not magic, and the answer is exactly what we're talking about today. So, that magic we were just talking about, it actually has a name. Polymorphism. It literally means many forms. And in this explainer, we're going to pull back the curtain and see exactly how it works and why it is so important for writing really elegant code. You know, to really get why polymorphism is such a game changer, you have to see what life is like without it. On the left, you've got this absolute tangled mass of if-else statements. Your code is constantly playing 20 questions. Are you a string? Are you a list? It's rigid, it breaks easily, and it's a total nightmare to update. But then you look on the right. With polymorphism, it's just one single clean action. The code becomes flexible, and suddenly adding new things is a breeze. So what is it really? Here it is, the big definition. Polymorphism is all about one interface, many forms. It's this beautiful idea that we can ask different objects to do the same thing by calling the same method, and each object will just know how to do it in its own special way. This right here, this is the aha moment. Look, if there's just one thing you take away from all this, let it be this simple, powerful idea right here. The whole entire concept boils down to these two lines. Same method name, different behavior. That is the beating heart of polymorphism. Okay, so we know the what and the why, but what about the how? How does Python actually pull this off? Well, let's unpack the most common ways you'll see this in action, starting with the classic approach that's common in a lot of object-oriented languages. So, this classic approach usually starts with something called inheritance. Let's imagine we have a very general or parent class. We'll call it animal. And this animal class has a method called speak. But you'll notice it's super generic. All it does is say, the animal makes a sound. Pretty boring, right? Now, we create what are called child classes, like dog and cat, and they both inherit from our general animal. But here's the crucial part. Each one provides its own much more specific version of that same speak method. This is what we call method overriding. The child effectively replaces the parent's generic behavior with its own specialized one. And this is where the magic really happens. Look at this loop. We're just telling each animal to speak. Notice what's missing? There's not a single if statement in sight checking if it's a dog or a cat. We don't have to. Python itself figures out which specific speak method to call at the very moment the code is running. That's called dynamic dispatch, and it is polymorphism in its purest form. But Python has its own special flavor, its own philosophy, and it's captured perfectly in this famous saying. This idea is the secret behind Python's uniquely pragmatic and flexible approach to polymorphism. Now, this is where things get really interesting. Take a look at these objects: a car, a bird, a person. They have nothing in common, right? They don't share a parent class or any formal relationship, but they all happen to have a method called .move. And for Python, that's good enough. Python says, I don't care what you are, I only care what you can do. If it has a .move method, I can treat it like something that moves. This is duck typing, and it's an absolute superpower. You know the wildest part about all this? You've already been using polymorphism probably every single day you've coded in Python, and you might not have even realized it. It's baked right into the language, hiding in plain sight. I mean, just think about the humble plus sign. When you give it two numbers, it does addition. When you give it two strings, it does concatenation. That's the exact same operator, the same interface, providing totally different behavior based on the type of objects you give it. This is a form of polymorphism we call operator overloading. And here's the cool part. This power isn't locked away just for Python's built-in types. You can do this too for your own custom objects. By implementing these special methods with the double underscores, we call them dunder methods, like underscore add here, we can literally teach our own vector class what to do when it sees a plus sign. It makes our code so much more intuitive. Okay, theory is great, but how does this actually help you build better software in the real world? Let's talk about building like a pro, using a polymorphic architecture. So let's say you're building an e-commerce site, right? You need a payment system. The polymorphic way to do this is to first define a common interface, maybe a base class called payment method. Second, you create your specific implementations, like a credit card class or a PayPal class. And third, you write your main logic, like your checkout function, so that it works with the general payment method, not the specific types. And this is the whole point. This is the big win. Your core checkout function never, ever has to change. It just calls .pay. Tomorrow, your boss comes and says, we need to add Apple Pay. No problem. You add an Apple Pay class with a .pay method, and that's it. You don't touch the checkout function. It just works. That is the power of extensible design. All right, let's bring it all home. We're going to recap the big ideas from this explainer and, just as important, point out a few common traps that beginners often fall into. So the number one red flag, the thing you want to avoid, is scattering if instance of all over your code. The moment you start manually checking an object's type, you're fighting against polymorphism, not using it. The whole point is to just trust that the object you have can do the job, whether it's through inheritance or because it's the right kind of duck. So to wrap it all up, here's your polymorphism cheat sheet. Remember the core idea: same name, different behavior. The main ways to get there are method overriding, where child classes get specific, and of course, Python superpower, duck typing. And the real-world goal here is to write code that's flexible, easy to extend, and free of that jungle of if-else checks. And that's a wrap. So I'll leave you with this question for the next time you sit down to start a project. Are you going to build a brittle system full of rigid checks and conditions, or are you going to use the power of polymorphism to build something that's clean, flexible, and truly professional? The choice is yours.